Okay, I just want to make sure we can read the screen okay. I've already recorded one lesson that was 30-minute recording, and when I watched it, the whole thing was blurry. I had to do it over, so don't want that to happen again. So fingers crossed, it was a one-time issue. So we are moving on to section 6, 13.6. We've now been through exact values, we've learned reference angles, we've learned coterminal angles, we've learned where things are positive and negative. And really this lesson today sort of pulls that all back together and reminds us of everything we've learned to this point. So there's not a lot of majorly big new things in this lesson, but there are important things that the reason I bring it all back together is because it's so important as you move on to the next level. So 13.6, we're talking about circular functions. That basically means we're working with the unit circle. That means we're working with a circle that has a radius of 1. And we've already talked about this year, that as we move around this circle with a radius of 1, then if I'm going a distance of 1, when I go 1 this direction, I end up at the point 1, 0. 1 up on the y-axis, I end up with the point 0, 1. 1 on the x-axis to the left, I end up with negative 1, 0. And 1 down, I end up with 0, negative 1. As always, these notes are on SaintsNet if you'd like to print them off and follow along, or you can, as needed, pause and copy the notes as we go along, whichever you prefer. So as we move around this circle, the radius is 1. And since the radius is 1, so far this year, every time we've looked for sine, we've looked for y over r. And every time we've looked for cosine, we've looked for x over r. And we've already sort of talked about the fact that if the radius is 1, then when I divide y by the radius, I'm just dividing y by 1, so why not just write y? And I'm dividing x by the radius is 1, well x divided by 1 is just x. So for now on, as we work with the unit circle, we can simply think of sine as being the y-coordinate, cosine as the x-coordinate. This helps me because that means in terms of coordinates, they go in alphabetical order. X comes before y, cosine comes before sine. Boom, that helps me remember cosine is x, sine is y. Tangent, as always, comes by doing what? Y divided by x. So tangent would be still sine divided by cosine or y divided by x. So we don't have to build a triangle anymore to find our trig functions if we simply remember on the unit circle, sine is y, cosine is x, tangent is y over x. Of course, if the radius is anything other than 1, then yes, we need to remember the y over r, x over r, etc. So if we know a point on the unit circle, which they've given me in the example, and we know it lies on the terminal side of the unit circle, we want to find sine theta and cosine theta. Well, we don't have to draw this location and make a triangle anymore. We just simply remember sine will always equal the y value, which is negative 1/3. Cosine will always equal the x value, which is 2 root 2 over 3. As long as we're on the unit circle. We don't have to worry about figuring out what the radius is because the radius we know is 1. So that brings us to our exact values. We are going to go around this circle and label all the exact values. Again, there is nothing new on this circle. We have talked about everything on this circle. All students take calculus, helps me decide all sine, tangent, cosine, so I know who's positive and who's negative. My quadrantal angles are still the same. I have a radius of 1, so I know this is 1, 0, 0, 1, negative 1, 0, 0, negative 1. But as I move around the circle, we're going to list what our sine and cosine values are. At 30 degrees, what do we know sine of 30 degrees is? 1/2. That is my y-coordinate. At 30 degrees, what is cosine of 30 degrees? Root 3 over 2. That's going to be my x-coordinate. How would I get tangent if I haven't memorized these? I would do y divided by x. So I would do 1/2 divided by root 3 over 2, multiplied by the reciprocal, 1 over root 3 equals root 3 over 3. So for those who've memorized tangent, you already knew that. If you forget it, you can always do y divided by x, sine divided by cosine. What's sine of 45 degrees? Root 2 over 2. What's cosine of 45 degrees? Root 2 over 2. Here's my x, here's my y. Tangent is y divided by x, so what do I get when I divide the same thing by the same thing? Y divided by x will be 1, so tangent is 1. 60 degrees. Who has memorized what sine of 60 is? Root 3 over 2, that's my y value. What's cosine of 60? 1/2, that's my x value. Tangent, I forgot to put tangent here, tangent is 1. Tangent is y divided by x, which ends up being root 3. So we come around to 120. I haven't memorized 120, but I have learned this reference angle. How far is 120 from 180? That's right, it's 60. So I just need the 60 value. So it's going to be 1/2 root 3 over 2. Which one's positive, which one's negative? Well, x is going to the left, so x is negative, so cosine is negative. Y goes up, so y is positive. What will tangent be? It will be negative root 3. Good. What's the reference angle for 135? 45. So it's the same values as 45. Who's going to be negative? The x. Good. Tangent will also be negative, and that's negative 1. And then finally, what's the reference angle for 150? 30. So cosine of 30 is root 3 over 2. Sine is 1/2. Which one's going to be negative over here? The x is. And tangent will also be negative root 3 over 3. Could we do the same thing with radians? Yes. So maybe it would be helpful to know your radian angles. So some of you may want to put that on here so when you study it's all on one page. What's 30 degrees in radians? Pi over 6. What's 45 in radians? Pi over 4. What's 60 in radians? Pi over 3. What's 120 in radians? Ooh, it's the same as 60, so we know it's over 3. What's that going to be? That's right, 2 pi over 3. What's 135 in radians? What's the same as pi over 4? And I'm not all the way to pi. That's right, I've gone 3/4 of the way to pi. 150 is the same as 30, so that's going to be the same as pi over 6. I've gone all the way around my taco, and I've got 1/6 left. If I eat all but 1/6 of my taco, how much of my taco did I eat? That's right, 5 pi over 6. Okay, let's keep going with the exact values. What would 210's reference angle be? How far is 210 from 180? 30 degrees. So what is 30? Well, that's the same as 30 up there. So root 3 over 2 and 1/2. Who's going to be negative down here in the T corner? X and Y. What will tangent be? Tangent will be positive root 3 over 3. What's 225's reference angle? 45 degrees. So that's going to be root 2 over 2, root 2 over 2. Who's going to be negative? X and Y, but tangent will be positive. What's the reference angle for 240? How far is 240 past 180? 60. So we know it's going to be 1/2 root 3 over 2, and they're both negative, and tangent's positive. And then finally, I like to have my reference angle, my radian equivalent. If I've gone 1 pi and another reference of 1/6, what would 1 and 1/6 be? 7/6. If I've gone 1 and another quarter, what would 1 and another quarter be? 5 pi over 4. If I've gone 1 pi and then another third of a pi, what would 1 and 1/3 would be? 4/3. Let's finish the reference angles. This has a reference of 60, which is the same as pi over 3. So I've now gone 1 and then all the way to here so that I have 1/3 left. So I've gone 1 and 2/3. What is 1 and 2/3? That's right, 5/3. This is the same as 45, which is pi over 4. So I've gone 1 and then 3/4 of another taco. I ate a whole taco, and now I'm going to eat 3/4 of another. I ate 1 3/4, which is 7/4. That's a lot of tacos. Miss Karma, I better watch out. And then what's the reference angle for 30? I mean, for 330, huh? 30, which is the same as pi over 6. So I've gone 1 and then another 5, 6, because this leaves me with pi over 6. So if I eat a candy bar and then I eat 5, 6 of another candy bar, how much did I eat? 11/6. Good. And then finally, the XY coordinates. Well, 60 degrees goes with 60 degrees. Who's going to be negative down here? Oh, it's going to be the Y coordinate because cosine is the X coordinate. √2/2 and √2/2 go with 45. Who's going to be negative? The Y value. And finally, 30 degrees gives me √3/2 and 1/2. Who's going to be negative? The Y value. And then tangent would also be negative. So let's move on to, is there anything new? None of this is new. It's just more practice because it's so important. Now the next thing is going to take these values that we've been learning, and we're going to learn what the sine function graphs and the cosine function graphs. In chapter 14, we're going to do a lot more with these graphs. These are just like the parent graphs. And then in chapter 14, we're going to learn how to shift them and stretch them and flip them and all that, squish them, all that we've learned to do this year. But for now, we need to learn the parent graph. And we could do this in degrees. I could just as easily have used, instead of 90, I could have used pi over 2. I could have used pi. I could have used 3 pi over 2. I could have used 2 pi. I could have used, what is that, 2.5. So that's 5 pi over 2, etc. Next year in pre-calculus, your teacher will take you from degrees to all radians, because when you get to calculus, all you will use is radians. But this year we go back and forth, and we actually rely a little more heavily on degrees because it's new for you. So, how do we figure out where the sine graph has values? Well, this is where the circle comes into play. So, around this circle, we know this point, we know this point, and actually, we know all the points in between, because we know this is 30 degrees is 1/2 √3/2, 1/2, and we know this is √2/2, etc. So we're going to figure out all the points. As remember, at 0 degrees. At 0 degrees, sine is which coordinate? The Y coordinate. Sine is the Y coordinate. So at 0 degrees, what is my Y value? It is 0. So at 0 degrees, this is my Y, and this is my angle axis. Angle is acting like X. So when the angle is 0 degrees, my Y coordinate, my sine value is 0. When I go to pi over 2, when the angle is pi over 2 or 90 degrees, what's sine of 90 degrees? Well, we know it's the Y coordinate, which is 1. When we get to 180 or pi, what is sine of 180 degrees? Well, it's the Y coordinate, which is back to 0. Could we fill in between angles? Sure. We could figure out what 30 degrees is. Sine of 30 degrees we've memorized is 1/2. So we'd have a dot right here about halfway up. Or we could do, 45 degrees, which is √2/2, which has a decimal with like 0.7. So we could have a dot at 0.7. We could have dots all the way. We don't have to fill all those in, but we could. 270. When we come around to 270, sine of 270 degrees is which value? The Y value, so we're down at -1. 360, we're back to 0. Sine of 0 or 360 is back to 0. 450, where does it put me? 360 plus 90, I'm back up here, so I'm back to 1. And so what I see to begin to take shape is a curve like this. And once I get back to 360, what does that curve start to do? It starts to repeat itself. It could have also repeated itself in the negative direction. Sine curves and cosine curves are called, I'm going to skip down in your notes and then I'll come back to the cosine curve. They're called periodic functions. If you skip down to these notes, periodic functions. What it means to be, and I'll come back to that. What it means, oh, Miss Conrad's picture is not very, look, I had made that hill too high. Let me make the hills a little more equal. Okay, what it means to be a periodic function, it means that I take the pattern from 0 to 360, and then I continue to repeat that in the same pattern. As I go around my circle, what do those values just keep doing? Repeating, repeating, repeating. This is a periodic function because every 360 degrees, I'll get the exact same values over and over. So I go from 0 to 360, 360 to 720, 720 to 1080, 1080 to, what is that, 1440. I keep repeating myself every 360 degrees, or in radians every 2 pi. Cosine is going to do the same thing, but the curves will not be identical. So let's move up and see what the cosine curve looks like. Okay, so I'm going to just keep the sine curve where it is just so you have a visual. But let's look at cosine. As we move around, cosine is which coordinate? Cosine is the x value. So what is cosine of 0 degrees? It is 1. What is cosine of 90 degrees? The x coordinate is 0. What is cosine of 180 degrees? The x value is -1. What is cosine of 270? The x value is 0. What is cosine of 360? I'm back to 1. And then what do? I start repeating myself. So I end up with a curve that looks like so. What do you notice about the sine curve and the cosine curve? They're very similar. That's right. The sine curve is simply, if I took this sine curve and shifted it 90 degrees to the left, so I took this point and moved it to here, and I took that peak that was here and I shifted it over. They're a 90-degree shift of each other. So cosine, sine, what do we have to remember? Sine, let me go back to the sine curve. Sine always starts at 0, 0. The sine curve starts at 0, 0, goes up to 1 at 90, goes back to 0 at 180, goes down to -1 at 270, goes back to 0 at 360, and then repeats itself. You have to learn this parent curve. You will need to be able to draw it from memory, not from notes. So you're going to want to remember where it starts, 0, 0, goes to a peak of 1, goes back to 0, goes back to -1, back to 0, because we in the next chapter are going to take this and stretch it and shrink it and shift it left and right and move it up and down and flip it. So you need to know your parent curve. Every 360 it repeats itself. Cosine, I went too high, didn't I? Cosine, where am I? Is right here, the blue one. Let me erase the purple one. Cosine does the same pattern every 360, but cosine starts at 1, then at 90 is at 0, then -1, then 270, then back to 1, and then what does it do? It repeats itself. So you need to start learning this parent graph now. You will be asked on the test to recreate the 2 parent graphs because in chapter 14 you got to do a lot of stuff to the parent graph. So let's move on and talk about what it means to be a periodic function. So a periodic function, in this case, is a function that repeats the same pattern. So you have a set length of time and then it repeats itself that set length over and over and over. For sine and cosine, the period is 360 degrees at 400 degrees, 2 pi and 400 radians, and the graph is just going to repeat itself indefinitely. It just never stops repeating the same pattern. The period that you measure is the distance along the x-axis from where the pattern begins until the pattern ends. You have some graphs tonight that aren't trig graphs that are repeating a pattern. You're going to measure out, oh, how far did I go before I repeat myself? So for example, maybe this is my graph. Okay, so I kept repeating that same pattern. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so that's 12, that's 18. Every 6 units, what do I start doing? Oh, I didn't go far enough. Every 7 units, what do I start doing? 7. From 0 to 7, what does my graph start doing? And I need to fix my graph. Sorry about that. Okay, so I went from here to here and started repeating myself. So this needs to go 4 units. So 1, 2, 3. I didn't take that far enough. 4 units. And then this went 1, 2 units. That was my mistake. So 2 units and then up. Okay, so 7, 1, 2, 3, 4, 5, 6, 7. So 14 and so forth. Okay. So every 7 units, I repeat myself. When I start repeating the exact same pattern, that's where I know my period is. So you would tell me that has a period of 7 units. Good. So how does knowing this help me? Well, since it repeats itself, when we get angles larger than 675, we just need to find where they're coterminal with the angle that's less than 360, because every 360 it repeats itself. So whatever 200 is doing, 560 is doing the same thing. And then 560 plus 360, 920 is doing the same thing. Are you with me? At 10 degrees, 370 degrees is going to do the same thing. And then 370 plus 360, 600, what is that? 730, going to do the same thing. Okay? So how would I figure out the exact value for 675? Well, the easiest thing to do is reduce it by 360 degrees. So what does that give me? Well, 675 minus 360 gives me 315 degrees. And then this is a problem we've seen before. Figure out where 315 degrees puts me. Where does it put me? In the 4th quadrant. What's the reference angle? 45 degrees. What's cosine of 45 degrees? Root 2 over 2. So 315 is also root 2 over 2. All students take calculus. It's positive, so 675 will be the same thing as cosine of 45 degrees. 420. Not sure where it's located, so let's reduce it by 360. What's 420 minus 360? Well, that gives me 60 degrees. I can get that one easily. What's sine of 60 degrees? I hope you've memorized these. That's right. Sine of 60 is root 3 over 2. These are coterminal, so 420 will be the exact same answer, because I just keep repeating the same answers. Negative 5 pi over 6. I'm not sure why I did negative 5 pi over 6, but the easiest thing to do, I think, is to figure out that it's here and the reference angle is pi over 6. But there are those who instead say, well, I'm just going to add 2 pi to it. What would be the common denominator? 6. Negative 5, 6 plus 12, 6 gives me 7, 6. So there are those who would prefer to go the positive way, 1 and 1, 6. Either way, you end up with a reference angle of pi over 6. Well, what is sine of pi over 6? That's right, it's 1/2. But then we have to look at the location, and where are we located? We're located in the same place as 7 pi over 6, which is the 3rd quadrant, so it will be negative. Good. And last example is in your book. Look on page 802. There is a Ferris wheel problem. They love Ferris wheel problems in this trig unit, don't they? This is second Ferris, or third maybe, Ferris wheel problem we've seen in this unit. So if we look at example 3 on page 802, I'm going to turn off the board so that we can have the screen to work on. Everybody have their book? Open it to page 802, pause the video if you need to so that you can open your book to page 802. And I don't have anybody to read it for me, so Ms. Conrad's going to have to read it. It says, as you ride a Ferris wheel, the height that you are above the ground varies periodically as a function of time. Consider the height of the center of the wheel to be the starting point. So in other words, I'm on this circle, this Ferris wheel. Here's the center of my Ferris wheel, you know, standing up off the ground. Here's the center, okay? But we're going to consider this where you start. So I start here. And then we move in a, does it say which way we move around the wheel? Doesn't tell me if we're moving we're going to assume counterclockwise so that we're working with positive angles in terms of Trig. So we're starting here. If this has a diameter of 38 feet, that would be this length here. If this is 38 feet, what do we know the radius is? That's right, the radius is 19 feet. The radius is 19 feet because the diameter is 38 feet. Okay. And it says, let's keep reading. A particular wheel has a diameter of 38 feet and travels at a rate of 4 revolutions per minute. So how many times am I going around this Ferris wheel and coming back to that starting point in 1 minute? 4 times. So if 1 minute is 4 loops, how much time does it take me to go around 1 loop? That's right, a quarter of a minute. What's a quarter of a minute? 60 seconds are in a minute, so 15 seconds. So 1 revolution equals 15 seconds. So we're going to make a graph to represent where we are as we travel around this Ferris wheel. We're going to let our x-axis represent time. We're going to let our y-axis represent how high in the air, our height above the ground, the height of our car above the ground. So when we start, if we're starting here, are we on the ground? No, we are. Now they are ignoring, obviously the Ferris wheel is not sitting, they're ignoring that little space here. We're assuming this is 0. So how high in the air are we when we begin? 19 feet. So at time 0, we are 19 feet in the air. So we start at 19. Then we move in a counterclockwise direction. And it takes me how many seconds to get all the way around? 15 seconds, that's right. So where am I, time-wise, when I get halfway around the circle? 7.5 seconds. And where am I time-wise when I get to the top of my circle? Well, I'm halfway between 7.5, which is 3.75 seconds. Good. Okay, and then obviously I'd go 3.75 seconds, 7.5, another 3.75, another 3.75, and I just finished my first loop. So at 3.75, how high in the air am I? If I'm starting 19 feet in the air, when I'm up at the peak, from top to bottom, how many feet is that? And Ms. Conrad just really messed up. And I don't want to record the whole thing over because it's the last example. So I didn't mess up badly, but I do have to change one thing on my graph. I'm treating the starting point like it's 19 feet in the air. But look at what I just drew. What does this look like? Looks like an XY axis, doesn't it? And it looks like my circle on my XY axis. And the reason they're telling me my starting point is here is so that I know this is like the middle of my circle. So if this is my starting point, it's not in relation to above the ground, it's in relation to the circle I just created here. Where is my starting point? Right here. That's my 0. At time 0, I am at a position of 0. Then 3.75 seconds after that, I'm how much above my starting point, not how much above the ground, and that's where I was messing up, but how much above my starting point. If this is my starting point, 0, I'm at my peak, how much above my starting point? 19. Now, we all know my starting point was already 19 feet in the air, so technically we're 38 feet in the air, but this is in relation to the cycle around the circle, not in relation to the ground the whole time. So my starting point is 0. I'm now 19 feet above my starting point. Then at 7.5, where am I? Back to my starting point. At the next point, where am I? I'm 19 feet below my starting point. And then I come back to my starting point, which is 0. So I end up with what looks a lot like my sine and my cosine curve. I started at 0, went up 19 feet, came back to my starting point, went down 19 feet, came back to my starting point, 0. In 4 revolutions, how many times am I going to repeat that pattern? 4 times. Every 15 seconds, my car is going to be doing the same pattern. So that by the time I get to 60 seconds, I'll have repeated this pattern 4 times. Sorry about the confusion. It's been a long day. This is my 4th video I've made in a row, and it's 6:30 p.m. So I think this means it's the last one I should make today. So we've got 4 loops, 1, 2, 3, 4, all repeating the same pattern, which means this is a periodic function. And if you have any questions, as always, during office hours would be a great time. Email me ahead of time. I could do a Google Meet with you if you need to do face-to-face questions, or just email me questions and I can try to type an answer back to you. So if you have any questions, let me know, and feel free to get started on your homework. Okie doke. Thanks. Bye.